Welcome to the Explainer. Today we're tackling something that is an absolute game changer for developers, loop engineering. Look, if you've been using AI to help you code, you've probably started with basic prompting, right? You ask a question, you get an answer. But today, we're going to transition away from those manual, one-off prompts. We're moving into the world of building fully autonomous agentic workflows using Claude Code. The whole goal here is to make the AI do the heavy lifting so you can actually step back and focus on the big picture.
Okay, let's dive into this and look at our roadmap. First up, what are agentic loops? Then, the evolution of loops. Third, maintaining code quality. Fourth, managing token usage. And finally, taking that first step.
Section 1. What are agentic loops? Let's demystify the buzzword.
Because to really scale our automation, we first need to agree on what exactly a loop is, right? You see this term thrown around everywhere on social media lately, but having a precise, practical definition is absolutely crucial. The Claude Code team at Anthropic defines loops simply as agents repeating cycles of work until a stop condition is met. Now, I love that. It sounds so simple, doesn't it? But man, it becomes incredibly powerful in practice. Basically, loops are categorized by three main things: how they're triggered, how they're stopped, and what specific Claude Code primitive you're using to run them. So let's break down what this evolution actually looks like.
Section 2. The evolution of loops. Going from manual tasks to full autonomy.
We're going to look at 4 distinct stages of loops here, and we're basing this on exactly what piece of work you are handing off to Claude. With each step, you remove yourself a little bit more from the equation. It's like unlocking more free time. So we kick things off with turn-based loops. These are triggered by your prompt, and they stop whenever Claude judges the task is done. Or, if it realizes it needs more context from you. This setup is perfect for those quick, short tasks. I mean, every manual prompt starts right here. You ask Claude to, say, create a like button, it makes the edit, and then hands back what it thinks works. At this stage, you're handing off the check to Claude. You might even use custom verification skills so it can test its own code end-to-end, but you are still driving every single turn manually.
Now, let's move forward and see how this builds naturally into goal-based loops. You do this using the /goal command. These are still triggered by a manual prompt from you in real time, but they only stop when a specific goal is achieved or a maximum turn cap is reached. This is absolutely your best bet for tasks with verifiable exit criteria. By defining deterministic success criteria, like say, passing a specific number of tests or clearing a certain score threshold, you're now handing off the stop condition. Think about that. You no longer have to sit there and judge if it's good enough. Claude just iterates automatically until the math says it's done.
All right, next up we have time-based loops. This uses the /loop and /schedule commands. Notice how the trigger has totally changed here. These are actually triggered by time intervals. They're perfect for recurring work or anytime you need to interface with external systems. Think about stuff like checking pull requests that might fail CI or summarizing all those crazy morning Slack messages. At this stage, you are handing off the trigger entirely to the system. It just hums along in the background on your machine or up in the cloud, and it only stops when you manually cancel it or when the queue of work is completely empty.
And finally, we reach the absolute pinnacle of this evolution: proactive loops. These are triggered by events or schedules, and get this, there is zero human involvement in real time. The routine runs continuously until you turn it off. That makes it ideal for well-defined streams of work. Think bug triage, massive migrations, or dependency upgrades. By combining features like dynamic workflows and auto mode, you have successfully handed off the prompt entirely. The system literally goes out, looks for the work, defines the goal, triages the issue, and reviews it. You've achieved full proactive autonomy. Pretty wild, right?
And this brilliantly illustrates the entire evolution we just talked about. It shows exactly what you're handing off at each stage and exactly what tool you should reach for. Just to recap, with turn-based, you hand off the check. With goal-based, you hand off the stop condition. With time-based, you hand off the trigger, and with proactive loops, you hand off the prompt itself. Honestly, keep this in your back pocket. It's a perfect cheat sheet for understanding how to scale your use of Claude Code depending on what you're actually trying to achieve.
Section 3. Maintaining code quality. Setting up guardrails for your agents. So now that we know how to actually build these incredibly powerful loops, we need to shift gears for a second. We have to talk about how to safely manage them. Because let's be real, an agentic loop is only as good as the environment it's running in. The quality of a loop's output depends heavily on the system and the guardrails you build around it. So here are 3 actionable steps you can take to ensure high-quality outputs. Number 1, keep the codebase itself clean. Claude is smart, but it's going to follow the patterns and conventions that already exist in your code. Number 2, give Claude a way to verify its own work. You can literally encode what good looks like for your team using skills, which lets Claude check its own homework.
And number 3, and I cannot recommend this enough, use a second agent for code reviews. A secondary reviewer with fresh context isn't influenced by whatever the main agent was thinking. It totally removes bias and gives you a much more objective check on the generated code. It's exactly like a human peer review.
Section 4. Managing token usage. How to keep your automation costs in check.
As you start scaling up from those basic manual prompts to the massive dynamic workflows we were just talking about, your token usage is naturally going to climb. It just is. So managing these token costs becomes a critical priority for any developer designing loops. Let's rapidly fire through some best practices to keep those costs down. First off, choose the right primitive and model. Smaller tasks, they don't need giant, expensive models. Next, make sure you define really clear success and stop criteria so Claude actually finishes efficiently and doesn't just run forever. Also, always pilot before doing a large run. Dynamic workflows can spawn hundreds of agents super quickly, so test it first. Oh, and use scripts for deterministic work. Running a basic script is so much cheaper than asking a large language model to reason through repetitive steps. You also want to match your checking intervals to how often things actually change. And finally, keep an eye on things by constantly reviewing your usage. You can use the /usage, /goal, and /workflows commands for that.
So, the crucial point I want you to take away here is this. Your model and effort level choices are among the biggest levers on what a loop actually costs. You have to be strategic. Throwing the absolute most capable model at a simple recurring problem, that is a super fast way to just burn through your budget. You really want to align the power of the tool with the actual complexity of the task you're throwing at it.
Section 5. Taking the first step. Getting started today.
All right, we've covered a lot of ground in this explainer. We talked about the theory, the evolution, the guardrails, and the costs. Now I have a challenge for you. Think about your day-to-day. Pick one task where you are the bottleneck. Just one. Which piece of that could you hand off to Claude today? Could you write that first custom verification check? Could you define a crystal clear deterministic goal? Don't wait until you have some massive, complex, dynamic workflow perfectly mapped out on a whiteboard. Just find one recurring bottleneck right now and build your very first loop today. Thanks so much for joining me on this explainer, and hey, happy building.